Hi, everybody. We already introduced ourselves, but once again, we're the Bilimetrix capstone team, and we're here to present our full year capstone project. Starting off with our sponsor and our advisor. On the left, we have our advisor, Professor Michael Koenig. He helped a lot with our code navigation and gives a lot of feedback on the code we pushed, and as well as the team as a whole. And on the right, we have Dr. Richard Wenberg, who's sitting right in our audience. He helped us a lot with our scientific work, as well as a lot of the support system that we needed when navigating the team project up the scale. And this is our capstone team. We're up here right now, but from Dr. Raya Kierna and then myself, Shreya, Samir, and Hyman, we got really close this year and we formed a pretty good connection based on the amount of work that we were doing and kind of navigating the issues and challenges that we had to get.
Yeah, so starting off with what Bilimetrix actually is, Bilimetrix is a company that has developed point-of-care assay systems that's used to measure bilirubin levels in newborns. This is important to preventing a form of brain damage called kernicterus, which is caused by very high levels of bilirubin in the blood. This can be prevented by detecting these high levels of bilirubin early, which gives caregivers a chance time to intervene and lower the levels of bilirubin through things like phototherapy before they get to the point where it's actually dangerous and life-threatening. Kernicterus is almost completely preventable with early detection. If left untreated, it could severely reduce the individual's quality of life, leading to things like hearing loss, vision problems, cognitive loss, and in the worst case, sometimes death. The BILIMOBILE app is one of the solutions Bilimetrix has made for this, which is a plasma bilirubin assay tool that can be operated directly off the smartphone. And the reason for doing this is that kernicterus in developed countries like ours is almost a non-problem, as our medical professionals are equipped with the tools and equipment necessary to measure these high levels of bilirubin quickly and efficiently, therefore resulting in a more efficient treatment process. Traditionally, the measurements are usually done in a lab with expensive equipment, which is hard to come by in developing countries where there aren't as many resources. And as I talked about earlier, Bilimetrix offers BiliMobile, is a product that can measure bilirubin right off your smartphone. This solves one of the biggest pain points in the whole problem, as we bypass the need for a lab and expensive equipment completely. However, the system for reading what we call the test strips, which we'll talk about more in the demo, it wasn't super easy to use at the beginning of the project. It relied on the user taking manual individual pictures to capture the test strips, which are subject to human error, among other things that can affect the accuracy of the results and make the app hard to use sometimes. The whole goal for our capstone really is to improve this process for test strip capture, make it as seamless, easy, error-free as possible. And then moving on to our MVP, or the minimum viable product for our project, it really was to do exactly that. Throughout the course of this year, our group has focused our work as a team in a couple of key areas. We had 2 work streams going on this year. One of them aimed at developing a fast and efficient error detection system that aids our image processing pipeline in quickly identifying issues in the test strips. Another work stream focused on improving the process for test strip capture itself, which leveraging the error detection work to provide the user with quick and actionable feedback for them to mediate the issue. Ultimately, the goal of our MVP is to provide a seamless experience to test strip capture, similar to using the self-checkout at your local grocery store.
Before we get into the work that we've done this quarter, it's important to talk about why this is important. So the Bilimetrix system that our app uses, the Bilimetrix system that our app uses is only useful if the results are reliable. So we have detectors in our pipeline, and those detectors are asking a yes or no question about images. So things like, is the camera or is the test card aligned, or is the lighting correct? And if any of these questions gives the wrong answer, then the system doesn't stop there with the error, but it keeps moving, or it used to keep moving silently. So what you would get is a bilirubin reading that it seemed valid, but was not. And in a clinical setting, this could be a risk to anyone's health.
Building off what Kieran said, for our detector work this year, we had an original set of detectors that were ported over from the website version of this app. Our work this year has really been to calibrate these detectors from the website to work on the phone. In this process, we have also removed some irrelevant, overlapping detectors in the detector suite, as well as greatly simplified and improved the error detection logic for them to better actually detect the issues that we're actually trying to find. These detectors detect things like unwanted hue in images, in-app brightness conditions, image hemolysis in the blood sample, bilirubin not being present in the blood sample, in-app framed images, among other issues. These issues service back up as error messages to the user, which contain actionable feedback to help them determine the next best course of action to mediate the issue. And on the right there are some issues showing the types of problems that we're actually trying to detect with them.
So to pull everything together, our detector work has touched every layer of our pipeline. We have been rethinking the system as a whole and how it decides whether or not an image is valid. Oh, I'm so sorry. Okay, it is that we've been rethinking the system as a whole and how it decides whether or not an image can be trusted. So, it's like moving beyond the calibration and the cleanup work that we've done, we also integrated the detectors into our camera pipeline. So now when users taking an image, it gets real time, or they get real time feedback rather than after a result has been calculated. So the result is a pipeline that's more accurate. And it actually talks to the person that's holding the phone. So it's very helpful to clinicians.
Towards the beginning of the year, we decided it was beneficial for us to completely refactor the camera flow of the app, starting with our flow chart over the right. So here we can see a pretty high level flow chart, which kind of goes through the process of taking the photo, which we open the camera and set up and align with the test strip, and our new feature with the auto capture system fires. With our auto capture system, we're basically able to take multiple photos in a rapid succession with just one click. Using that, we're able to average out the values that we get from each capture and provide you with a more accurate photo grid. In addition to making the app more efficient, we also aim to improve the ease of use. Here, we added Zoom feature, which is aligned with your native app, and so it made the process easy from transitioning to using your camera app day to day to using Outback. In addition to that, we also added errors to real time as well as after the captures are done to make sure the user can correctly see what is wrong with the photo to get more accurate readings. So over here on the right of the screen, you can see plus and minus symbols to demonstrate that we have a zoom feature. And then on the right, let's go to the next to that photo. We're able to see that there's errors listed there for how badly the photo was taken and for the user to go ahead and remediate those issues so you can get an accurate reading.
Okay, so let's see how our app works. So for this slide specifically, we're going to go through a quick user scenario for our sample persona, Carrie. So Carrie is a caregiver from a remote village who needs to perform a bilirubin test for a baby. But in the area that she's in, there's no internet, and she doesn't have access to the proper medical equipment that is needed to take a fully successful bilirubin test or to detect if the baby has jaundice. So she goes to our app, the BILIMOBILE app. So in order to use the app, she starts by taking a small blood sample and putting it on the card, and she has to let it sit for a required amount of time. And after the blood card sits, she's able to use the app and take pictures. If you look on the screen for our diagram, we are moving from left to right. So starting from the home and ending at the home page again. So what we do here is we set the patient. So we select the patient based on what the clinic is and what the caregiver wants to choose. And once you select the patient, then you go to the capture sequence. So Carrie uses the app to take photos of the test card, and the app takes 3 photos in order to process it and return the bilirubin value. Using the value, Carrie is able to determine whether the baby needs immediate medical care or is at a point where it's not as severe and can recover with the equipment that they have. Now we'll go on to our demo. Okay, so as you can see on the screen, that is our homepage for the app. And where it says my name, Shreya, that's the patient. That is the caregiver. And that was the capture page, and now we're on the take a photo page. So here you can use the zoom buttons and the alignment navigation assistance on the screen to align the test card with the alignment system that we have so that we get the most accurate reading. The processing tool is taking 3 photos, and as the blue circles progress, that's 3 photos being taken and processing, and we get a summary of the readings and as well as the average readings so that the caregiver can make a decision. You're also able to go see what kind of images the app was taking, so you can see if it was accurate or if you need to retake it. And then you can go back to the home screen, and when you take another image, you can do that or finish use of the app.
Here, I kind of want to talk about just an overall view of how we work together as a team, as well as some of the technical stuff that we achieved. And so our roles during this year were separated into 4 different parts for 4 members. So Shreya was the project manager, leading the team and meetings as well as making sure the task. Kirna was the lead facilitator, making sure that we were all held accountable for when we need to do our sprints tasks. I was the project secretary, making sure that those were taken in meetings, making sure everyone had the information that was needed to achieve our goals. And Jaime was the outreach coordinator, often reaching out to the sponsor and advisor for help and assistance or information on the route. So for the more technical stuff, for the 2 projects that we had, we were able to commit 396 times for the image, 171 times for the mobile, and both had 99% coverage to ensure no errors were leaked through.
As a team, we've been holding ourselves accountable by holding daily and weekly check-ins, which helped us work through blockers a lot faster rather than letting them pile up. We also have been very intentional about communicating with each other when something goes wrong, whether it be a technical issue or something or a gap in coordination. We also have made code reviews and collaborative coding sessions with our advisor, a very integral part of our work process. So that kind of structured collaboration is what allowed us to ship what we have shipped. And to wrap everything up, Bilimetrix is doing work that really has an impact. Being able to get bilirubin testing into the hands of clinicians in low resource settings with only a smartphone has the potential to prevent real harm to newborns who otherwise wouldn't have access to that kind of timely screening. Our contribution this year has been to make that system more reliable. So by improving detectors, streamlining the camera flow and reducing the gap between what a phone can capture and what a clinician can actually trust. We're very proud of the work that we've done, and we're grateful to Bilimetrix to have the opportunity to work on something that matters. Thank you.
Let's get into the Q&A session. You have any question, just ask them.
I'd like a question. If a newborn does have a high bilirubin, do you go into, I used to remember Lights that you put the babies under to help reduce the bilirubin? Do you study that at all, or just the level of it?
Our app is purely diagnostic, so we leave it up to the caregiver to decide what to do next.
Thank you.
And thank you for the project presentation. So what was the learning curve and how did you navigate?
So for us, I think when we first got our code base, it was a little hard to like understand what exactly we had to do since there were so many features and so many things to navigate. But our advisor was able to help us a lot, as well as our sponsor, and they both were able to like help us and guide us through making the best out of the time we had and making sure that we were efficient and getting started with them.
I can add on to that as well. So there's obviously like a big science component to this project, and working, not just me, but like everybody working with our sponsor over there. It's been helpful to translate that science context into like actual code. So I'd say that's the biggest work.
What would you say was your favorite part about working on this project?
I think I really do like and appreciate the fact that this app is like currently in use and does help people. It's kind of a scary world right now, but like knowing that you're actually like contributing to the greater good is a really good feeling. Like clinics in Nigeria, Malaysia, and Vietnam are currently using the app and saving babies.
Yeah, just to kind of add, I apologize, but just kind of add on to that, I think kind of seeing how it works throughout the whole year, it's probably one of the largest projects we've done, like each other, and so it's nice to see kind of like how our work kind of bonded together as a team and was able to, like Kara said, produce something that is useful day to day.
First of all, I want to thank you guys for presenting this. You guys did a great job. And then just the fact that you're focusing on this is my question is, it seems like your focus population is developing countries, right? So I mean that the tool is you're talking about apps and that require a smartphone, it seems to me. And there are countries who may not have a smartphone available. If we want to reach that population, is there any other option that's considered?
The reason why we focus, or the focus of this project and company and app on low resource countries is because bilirubin testing does exist, but it's very time consuming and it's very expensive. Our app is made specifically for Android phones because they are more commonly used in developing countries. But we try our best to cater to the clinicians' needs, but also usually in hospitals and such, they have like work phones.
We also try to cater to like the most cost-effective solution. So that's what we Android as Serena said, because price-wise, it is a little cheaper to get for like clinics on larger scales. And it's also more user intuitive when you like look at our app, especially for like, the size of the screen and the availability in developing countries. So we kind of target like hospitals and caregivers that have access to like at least a smartphone, so they're able to access our app. Thanks.
Are there any other further changes you would add if you have more time allotted for this project?
So with our camera sequence, we like Ivan said, we wanted to kind of get it to a point where we would just scan the phone over the tester and it would instantly capture kind of like a grocery scanner. But unfortunately, due to like technical difficulties as well as trying to keep it cost effective and making it work on any phone, we couldn't get that to work. So that's probably one of the things that we try to investigate to try to like create that.
Interesting.
Any more questions? If no, let's test them again for their. You get the impact. That's the set operator. Let's have set up first. So yeah,
Hello?
Yeah, next talk is from Metabolic Resources. Let's welcome them.
Hello, everyone. Thank you for coming. I have a question first. Do you or a family member have a child with MCAD? Oh, there's one in the audience. Perfect. Well, we understand that waking up in the middle of the night is hard enough as is, but keeping track of when to feed, who fed last, and what was fed, it's all a nightmare. So together, we decided to come up with a solution. My name is Henry, alongside my teammates Leo, Shahryar, and Rocco, our advisor, Michael Koenig, and our sponsor, Rachel McKee. We decided to build MCAD app. One app that centralizes all these tools and helps caregivers manage MCAD efficiently. But before we get started, let's understand what MCAD actually is.
So MCAD, or medium chain acyl coenzyme A dehydrogenase deficiency, is a metabolic disorder that prevents the body from converting certain fats into energy. And when a child with MCAD goes too long without eating, their blood sugar levels can drop dangerously low. And this drop can cause a lot of severe consequences like loss of consciousness, coma, seizures, or in some cases even death. So for most families, forgetting a snack could be a minor inconvenience, but for families living with MCAD, it could be a major health emergency. And this isn't just a hypothetical scenario. Our product sponsor, Rachel, has a child with MCAD. And as we spoke with Rachel, she described what that experience was like. Feeding schedules need to be monitored constantly. Different care providers could be active at different times of the day. and important information can be scattered across notes, documents, alarms, or other messaging apps. All right, so let's get into some of these features. So as a primary care provider, one of my main responsibilities is to make sure that my kid eats at consistent intervals throughout the day. To do that, I go to the alarming page of our app where I can set a feeding interval. Once set, the app automatically tracks and resets this interval throughout the day and throughout the week. And once an alarm goes off, I can either answer it right away and start logging, or if I'm unavailable and can't respond, the responsibility doesn't just go away. It alerts the next person in the care team to ensure that the action never gets missed. Because taking care of a child should never depend on a single person being available at exactly the right moment. Now, once my child is finished eating, I can go to the food logging page where I can track what was consumed and when it was consumed. As you can see here, we can, or well, you actually can't see, but you can enter the calories, the carbs, the name of the food, and then also in notes as well for other information you want to add. And then we also have ounces for breastfeeding. These logs create a living history of care to help families track feeding feeding intervals and to make sure that they have information over time, maintain information over time. But feeding struggles aren't the only problem that comes to taking care of a child with MCADD. Most of the time, they're often other relatives, grandparents, or teachers or other care providers may step in to help, and they may not have as much information on MCADD. And when this happens, they need guidance quickly. So as an uncertain secondary care provider, I can navigate to the resources page where I can see a list of helpful websites and groups about MCADD, or I can navigate to the document section of the profile page where I can see uploaded documents or instructions, feeding plans, or emergency information that the primary caregiver has provided. So I know what to do and when to do it. Next up, we have a little demo scenario showing off what an escalation may look like for okay. What do my computer that thing? Right now,
Turn off your microphone. You can turn off your microphone.
Oh. That makes sense. I don't think it's these mics. Just read it and I'll try to talk through it. Okay, so in this scenario, I'm a primary care provider and my alarm is about to go off, but I know that my kid Tracy is with Rocco. So I don't have to worry about when the alarm goes off because I know it will escalate to Rockley's phone. That's the alarm going off.
So now the alarm escalated to my phone. So now I know that I have to now feed Tracy, who's with me now. So I can click stop alarm on my phone. And since I don't maybe not know as much about MCADD, I can navigate to the resources page and check if there's feeding instructions there, and I can view a document to see if maybe she has a favorite food or something like that I can check on. And then I can add the food log there, and her favorite food was pizza. So then I added that in, and then once I fill out this full log, a notification will get sent to Leah's phone saying that I have now fed Tracy.
And here I can see on the homepage where the pizza is, I can see my most recent logs. And then there's also the food resources page, food logging page. I can look at past food logs and see it there as well. And then we can play it again.
And this video demonstrated the capabilities of our app from A to Z.
And now let's dive right into the technology stack that makes the app. So for our technology stack, we use the .NET framework. For the first technology I want to discuss is Maui cross-platform app development. We chose Maui to develop an app for both an iOS and an Android, so that way we could use one code base to for two platforms and not have to do unnecessary work. Our primary language that we used was C# for backend and the front end logic. And our IDEs that we primarily used was Visual Studios for our members who are on Windows OS, and for Mac OS members, they used Rider by JetBrains. And for our cloud storage, we used Azure Blob Storage to store data and files and different records on there. And we also use GitHub to manage team collaboration.
The largest challenge that we ran into was our alarm reliability. Well, during fall and winter quarter, when I was developing and testing our alarm feature, I was testing on my one device that I had, and it worked as expected. And later on in the year, when I tested on a separate device, when I removed the app from recently used apps, the alarm did not trigger at the set time. Turned out the two Android devices work completely differently, and some Android manufacturers treat backend processes more harshly and close them when they're no longer in use, which caused our alarm to not be triggered. Due to this, we had to rework our whole alarming schema and had to develop a backend web server to handle all our alarming. So this web server now checks every team every 5 seconds, and if a team needs an alarm to go off, it will then send a notification to the phone, which will then trigger the on-device alarm and trigger the alarm. This did, though, increase our cost from virtually $0 a month to about $65 a month, which was a big cost increase as we were trying to keep this as low as possible. But due to the nature of having this such important feature, we needed that much, like almost close to 100% of the minimum.
Hello. All right, and as CS teams, we only knew how to build the software. We had setbacks visually. We had no visual identity, and our branding was inconsistent. And so that's where the Seattle University Design School came in. They helped us develop a plan, and they started with understanding our users and what they may need to see on our app. And so we went back and forth with feedback and iterations, and we made the product even better and better. At the end, we decided, and they developed us a visual identity. They helped us develop a logo, a interactive mockup, and a prototype. With these, they helped us develop that visual identity that will help us and helped us see the app through the eyes of the caregiver.
So for our team collaboration and project structure, we divided each individual task into based on an individual strength and team priorities. And each member had a specific component they need to implement. And we coordinated this via GitHub, where we would push and pull the code whenever we needed to. And we also held team meetings. For collaboration process, we used a Agile/Scrum framework, and we tracked tasks using again GitHub issues and milestones, and we had regular sprints where we held discussions on and did sprint planning. For the lessons learned, the Agile and Scrum process were really great during the spring and winter quarter early on in the project. We were pretty strict following the sprint process to the core. But as the spring quarter came, our priorities shifted and different things came up, including milestones that need to be hit. So our Scrum, we unfortunately could not follow Scrum that tightly. But we did try our best, again, to follow code reviews and team meetings and things like that.
So what's left and what we're leaving off to the next team that hopefully will take over this project is we were not, due to some setbacks with like the alarm and refactor, we were not able to fully complete our escalation chain feature. So currently that does not work and you're not able to set the customizable escalation chain as of yet. The framework is there though, so it just needs to be coded out in the app. And then next, we were hoping to also have iOS development at least started. But we were not able to get that, but due to the nature of Maui, most of the app will compile. It's just this platform specific code to iOS will not run. So the notification chain and the alarming will not work, but all other features will work as those are all cross-platformly coded.
At the end of the day, we developed something that never existed before, something new, and something that will help families hopefully act that they will actually need. And to conclude, we just want to give a big thanks to the design school for helping us guide us with that visual direction and help us make something that we're proud to put our names on. Another thanks to our advisor, Michael Koenig, that unfortunately couldn't be here, but we want to give a big thanks for him holding us accountable, supporting us along the way, and just dealing with us in general all year. And lastly, we want to give a big thanks to Rachel McKee and the MCADD Metabolic Resources for just bringing us into this community. It's very rare metabolic disorder, and the community is just very small. So we're just grateful for this experience. And once again, my name is Henry.
I'm Leo.
I'm Shariar.
Morocco.
We're Team CS 2610, and we're thank you.
Let's get into the Q&A sessions. Any questions regarding Pocock and their app?
Yes.
Yeah, so you mentioned you were had a few improvements or like those 3 features that you were going to add in the future, but if you were to reduce that infrastructure cost, is there any features that you could streamline? How would you go about if that was a goal?
I mean, we could. There's probably ways we could like reduce infrastructure costs, but then that would also leave the like alarm to be like vulnerable. Like we could have got stuck with what we had, and it's just the only time the alarm wouldn't go off is if you swipe the app up. Every other situation, if the phone rebooted, everything like that, it went off just that one time. So we were trying to get as close to 100% as possible, which we thought was more important than keeping costs as low as possible.
How is someone, is it a newborn that's diagnosed with this, or how do you find out that you have this?
Yeah. So newborns get diagnosed, and then, I mean, we don't know too much about it. Yes. If you could, how would diagnosis work, actually?
There's a newborn screening in the state of Washington that's done when a child is born and then a couple days post-delivery. And it flags for different metabolic disorders and stuff like that. And then there's a genome sequencing that happens if they get flagged.
And
So
then
usually early on.
How many people are on the chain of?
It's just however many you want.
Okay, so you can pick 4, 3,
Yeah.
6,
And
whatever.
then you can set the order, and then you can also, it's highly customized, you can set the time for how long you want the alarm to be able to go off to 5 minutes, 10 minutes, 2 minutes, however long you want.
And will it, say I was the number 1 person, but I didn't pick up and it goes to the number 2 person, will it still keep alarming
Yes.
me too?
Yeah.
Yes. And then keep going down the line.
Okay.
Yes.
What were the signs that triggered the alarm?
The signs that trigger the alarm. So as a caregiver, you set an interval for say, let's say an hour. So every hour, the alarm will go off each time. You can.
What makes it go off?
The server, we have we call it a heartbeat, checks run through each team every 5 seconds and sees if the interval time has been like succeeded. So let's say we set it at 3 o'clock, we'll see if it's past 4 o'clock. And then it will send the notification to the primary user's phone. And that'll trigger the on-device local alarm and then start the timer on the server. And if we don't get a confirmation back from the phone before that timer is done, then the next alarm will get sent to the secondary user.
So it's cardiac alarm, is that correct?
Yeah, basically, yeah, yes.
Because there are a lot of these, what you have done here is could be applicable to many stimuli. There are, it's not just cardiac apnea. Stop breathing. Seizures. A lot of these processes can be very well served by what we've done.
Any other questions? Yes,
Just adding on, like, do you guys see any application of this app or this platform in other uses, or like how is the modernity of the platform in that vision?
Yeah, I mean, I could even see this as someone who may have problems, even like getting up to eat or getting enough food in the day. You can set your own intervals, like I want to eat at these times a day. I want to track what I'm eating. I want to make sure I'm eating the correct carbs, whatever, notes and all that. So more of like a tracking section for other people for general use. And then just like he said, there's probably way more other diseases or disorders that can depend or use this app to help them.
I have a question. How do you guys like plan to take the security on the data, protection the data?
So we don't store any real medical information about it. It's just the food that you're tracking and the information, and then maybe the care plans, like they should eat at this time, or they like eating this, or things like that. So we're not storing anything medical.
But the food that you're taking is quite important information about the person, right? So
Yes.
are you guys plan to do anything on that? Like
for
the food, even for the food?
I don't think for that right now.
Well, I mean, it gets encrypted to blob storage. So there's that encryption, and then there's no real restriction on the actual database, like from that point of view.
And then we have part of our privacy policy getting on the Android store, they can delete their information whenever they want.
Yes.
Any more questions? Let's thank them again for their good work.
Yeah. Yeah, it's really often today.
Alright, let's start by the third presentation, the IEEE and the Kilowatts for humanity.
Yeah.
Can you introduce yourself?
No.
All right, hello, everybody. Thanks for coming to our presentation. CSLA 6.09. All right, hello, everybody. Welcome to our presentation. We're at 26.09, working with Kilowatts for Humanity and IEEE on the SESDC toolkit. I'm Jackson.
I'm Evan.
My name is Victor.
And I'm Brian.
And our sponsor for this project is Peter Nemenhauer. He's he's a chair for the Kilowatts of Humanity. And our faculty advisor is Bruno Gardia Robles. And so our agenda for today is you first go over our mission statement, a little bit of background information about our project, why SESDC-TOOLKIT. We then go into a demo along with our architecture and tech stack, our team methodology, our testing and DevOps, and then our impact. So for our Kilowatts for Humanity mission statement, is to improve people's lives by providing access to electricity and fostering the development of sustainable businesses. Our volunteers offer mentorship and resources to empower less economically developed communities for lasting change. And currently, the bulk of their efforts have been in rural Zambia.
A little bit of background about Kilowatts for Humanity first. Kilowatts for Humanity is a nonprofit organization that is usually in Zambia or Kenya, and they build microgrids for communities that do not have access to power. And the little photo right there is a microgrid, which is basically a big power system, just small, and you have the solar panel, wind, generator, and then the only difference would be the main power grid would not be connected at all, and then you have schools, businesses, anything that needs power would be connected to it. So in rural communities, this is what they need to get access to power, internet, and everything that we have here. And why SESDC Toolkit? This toolkit provides an easy to use solution compared to Durcam or Homo Pro, which is a lot more technical, and volunteers don't have the technical knowledge to use this tool or to use other tools. So this provides a simple and easy to understand alternative to tools like that.
All right, so I'm going to be going through our demo of our website. So one of the main things that we changed this year was that we reworked the whole front end and look of the website. So here we're going to our about page where you can find information about the mission, the companies involved, and the capstone teams that have worked on it in the past and future. Here we're going to go up to our contact page where users can contact the developers and send questions or any bug reports and that kind of stuff. Now we're at our help center. So this is basically a good place to go when you first start up using the app. It gives you, introduction on how to use it, who it's for, and it just gives you a lot of information regarding how you want to use the application. As you can see, there's some benefits, some technical details like supported browsers and how to use the app and manage your account, etc. We're just going into more of the help and the other stuff. Also, you can find us on social media at the bottom. And then now we're going to log out and log back in. And then second. So this is our account management page where you can save any preferences on emails or update your account's passwords or delete your account should you want to do that. So now we're going to log back in and go to our projects page, which is the main portion of this project. So here's the dashboard where you can view your projects. So right now we're going to create a new project from the first time user view. So this is our project wizard that basically allows the users to have a guided walkthrough on how to set up a project from the start.
Most of the volunteers don't have electrical engineering experience, so they don't have a lot of background info on a lot of these statistics, like what the different battery types will do, charge rate and capacity. So this kind of bridges the gap between the knowledge gap between our users. Here, we're filling it out through the tutorial. And all the stuff. Here's the wind step, gives you some background information on the optional wind turbine generators. And then here's the final page. You can do all the last minute setup, and you can see some summaries of what it's going to kind of look like based on your load preferences. And then here our users can make some last minute adjustments to the project to set it up. And now that they've created the project, they can then create components. So one of the main features we did was nested components and component-based loads. So as you can see, we have load 1, which is a business building. And then within that, we're going to nest all of the additional loads like lighting, air conditioning, TV, etc. And then that will then be accumulated and added up. And then that will be one total load for just the business, as opposed to each individual application. Here's our graph page. It used to be static graphing, but now we have a dynamic graphing interface where you can display the data visualized, and you can stack different data sets on top of each other and change the zoom load. Most of our calculations are a 20-year plan. So the different zoom levels is very helpful to see different parts of the years, how your energy consumption will change over time. And then here's our data section. This is just the raw data in CSV format that we're displaying on the graph. You can download it here or just view it if you want to. And this is just a easier way to the raw data should you want that. That's our demo. So I'm going to give a little bit more context about some of the features we've been developing this year. So the first one would be our component-based loads that I talked about. So basically this means that the loads are not independent, they can be nested within each other. And then that makes it a little more user-friendly and makes more sense when you're actually looking at the statistics behind the loads. We added time-based loads, so you can have a light source that has different amount of electricity used throughout the day. So obviously the lights aren't going to be used as much during the day as night, and the AC will be used during the day more often. We have the dynamic data visualization. Because the old one was a static matplotlib graph, we wanted to make something more user and interactive. We also have a robust system and account management. So we implemented more authentication for our users and security around the data handling. And then we also added more freedom with how they want to manage their accounts.
All right, as for our architecture, we were given this project and it was written, the front end was written HTML, CSS, and JavaScript. And when we were looking at the code, everything was clumped together in single files. And we wanted to break that up because we wanted to use other components. So we picked React at first, and because that is a more familiar framework that a lot of people use for front end. But one of the requirements that our sponsor wanted was to have a lighter packet size, or a lighter front end, basically. So we found Preact, which is a much lighter React alternative, and it's around 80% less of the packet size that React potentially would show. As for styling, we still use CSS, and in the backend we used Google Firebase. This was mainly chosen because the sponsor had a free tier account already, and we were able to make the most of it. And it came with a backend, Google Firestore, which is a database, NoSQL database, and it was really easy to use. And then we use serverless functions that were also a part of Google Firebase. And this is a high-level diagram of what our architecture is like. If we start from the top, our users see our Preact front end, and the Preact front end connects to the backend, which our server is run on serverless functions, through Firebase functions, which connect to our database Firestore. Then we also have authentication that is built into Firestore. Cool. Now for our team methodology, we used the Kanban board. Most of our meetings with our sponsor, we spent just looking at our Kanban board, our backlog, what we had in progress, and we sorted cards together. This worked really well for us. And our flow was every week we would meet 2 times. And the first time was with our sponsor, which would wrap up our sprint. We would just kind of look at what progress we've made, so a demo, and then we would have a retrospective where we look at what we've done and then see how we can improve for next time. And then the second meeting that we had was with our faculty. And it was more of a check-in meeting, and we were sorting our backlog so that we can prioritize what to work on for the next sprint. As for working together as a group, we had good asynchronous communication through text messages, and we had a lot of PRs, pull requests, and code reviews. So that worked out pretty well for us. Gave us enough time to have focused time for ourselves.
Now onto our testing suite. So we utilized Vitest and PyTest for our front end and our back end. We chose Vitest because it's works seamlessly with what we had in our front end. And we utilized integration tests for our Firebase. This basically made sure that everything that we wanted to do with our database was connected and that it worked. We said unit tests for our individual components and logic, which ensured that everything worked well, as well as our end-to-end tests for our intended MVP happy path that ensured that our user flow worked well. And for the Python side of things, we utilized PyTest, had unit tests for our Firebase function utilities, and this made sure that all of our Firebase functions worked properly and worked within the project page.
All right, and on that same note, we integrated CI/CD, continuous integration, continuous development through our GitHub. And these unit tests that we wrote, they trigger on created pull requests so that we can have a gate for if our code is good or bad. And another thing that we had on our CI/CD was an automatic deployment of our front end and automatic deployment of our back end. So that made it really easy for us to see our changes in the live production environment.
All right, so I'm going to go over a little bit of the future work and what we're going to be handing off to the next capstone team and what they can maybe expect to work on. So one that we want is local workbench tabs. As you saw on the projects page, you have to actually select each project and it'll display the loads. But we kind of want to have a tab view where you can, let's say you're working on multiple projects at once. It's easier to seamlessly switch between those and view them. We also want to have more customization with the toolkit, maybe implementing filters for the graphs in different ways you can customize the load profiles. We also want to have better sharing and organization. So what we mean by that is users on our platform in the future maybe want to have an integration where we can share the projects between each other. This will make the volunteer collaboration way easier to do between volunteers. And then finally, we just wanted to have manual saving and an undo function. So basically, whenever you enter a load, it auto saves and propagates our backend, but we want to make a manual save option so you can kind of fiddle with it around. And if you make a change you don't like, you can then undo back to a previous state and not compromise your project.
And finally, for our impacts, our project has huge benefits to communities that don't currently have power. Planning is the first step. This project makes it a lot easier to get their foot in the door and talk to volunteers, talk to like government and start planning. And sorry, Yeah, this is the first step to get started, and yeah, this is the first step to get started. This is what nonprofits need and the other volunteers in the community. And KWH has already done a lot of projects in the past. They've currently done 8, so this will allow them to get a lot more done in the future.
Let's get into the Q&A session. Any questions?
On your slide about your team dynamics, you had a bullet that said async stand up. One, if you could explain that, since that's kind of an oxymoron. So what is it and why did you do it that way?
Yeah. I guess kind of what I meant by that is a lot of the time when we have the pull request up, we would send it to our group chat, and then we would then, you know, say I'm looking at this, and then we give those asynchronously, not live, and then yeah, it's just kind of how we would review each other's code.
Yeah, and a lot of times we wouldn't do it every day, but we would do maybe every other day. We would check in through text saying what we did and what we're working on and what we're blocked on. And if we're blocked, then we would send that more immediately. But yeah, just give each other updates.
Just check-ins.
Yeah. Any more questions?
When it comes to the nonprofits engaging with this, or someone who has to manage it, is there some sort of translation for them so they understand how much power is being consumed or any of that in simple, I guess, trying to simplify it for them?
Yeah, so I guess the goal of this in that context is that the volunteers and the organizations planning for a project in the microgrid would use this as a way to better plan and organize their data. And then, so since they are a nonprofit, they have to apply for grants and funding and fundraisers and stuff like that. So in that the nonprofit space, having clear projections and predictions on how much it's going to cost, what kind of energy you need to use, it's going to make it way easier to secure funding. And also one of the core things that we wanted to do was that when setting up a microgrid, you don't want to over-engineer it. And so you want to make it as close to the needs of the community as possible. Because if you generate too much energy, there's not as much of a battery space. So you don't want to waste it. So you try to make it really accurate to what the community needs.
Also, another part of that would be our tutorial in our demo. It had little subheaders, a little like description to help the user kind of determine like what their prospective microgrid would like fall under. We had like the residential, the commercial buildings, as well as like the small, medium, large. Because most people, I know me, for example, I didn't know how many kilowatts of energy that me and my roommates were using. So there is a little indicator that helps guide you into the range of the microgrid.
I have a question. Is it browser based or is it phone based?
It's a browser web app.
Are you going to make it like a phone based app or?
I think it's compatible with mobile. So I think the goal of the project is that one of the things that we want to use is that a lot of people in Zambia have maybe older phones, Androids, and low bandwidth is a big concern as well. So we wanted to keep it as a web app that's really lightweight, so you can use it practically anywhere or on any device.
So I know it's a browser based. Are you planning to add any security authentication because so that people don't use and then nobody can hack it, right? Especially if the grid, it's connecting to the grid and then also working on it. Right?
Yeah, some of the improvements we made this year were security based. I think the Google database is encrypted as well. Yeah. Any more questions? Thank you.
Let's set them again for
Welcome, everybody. We are now starting session 2 of our project state presentations in this room. We have 3 teams very eager to present, very happy to be completed with their projects, and this close to celebrating. Welcome all. Thank you so much for being here. I'll be your MC for the session. I am Professor Diaz, and this is actually the team that I advised this quarter. So I'm very proud to be here seeing them present. I'll try to keep things moving so that we are on time. And with that, we have Washington Business Week.
We are Washington Business Week. My name is Tien, that's Isaac, that's Gordon, and that's An. Our lovely sponsors is Nick Quaylen, Gary Toe, Brian Pocock, and our lovely faculty advisor, Professor Diaz, right here. Yeah, so through the agenda, we're going to start off with talking about the scope. Then we're going to talk about our design decisions and technical stack. Next up, we're going to do the demo. And after the demo, we'll go through reflection and future plans. And lastly, the conclusion. So we are going to get started with the scope. And in order to know the scope, we're going to talk about what the organization actually is. So Washington Business Week is a nonprofit organization that hosts week-long camps that teach high school students about businesses. The way it works is that students get in groups of 8 to 10 students. They have a mentor. They make up a company name, make up a company product. And throughout the week, they do icebreaker activities and other games. They present their makeup product to industry professionals. And one of the core foundations of their camp is an enterprise resource planning simulator. An enterprise resource planner is an application that hosts many different department functions into one application, such as HR, inventory, and sales. And that's how businesses can keep track of different functionalities in one place. The reason the Washington Business Week does this is so high school students can dip their toes into different departments of business. And this is exactly what we have made. You will see it in the quarterly decisions. That's what it mostly represents. And so our scope and goal is to rework the business simulator while keeping the core calculation fundamentals. And the rework is to increase its maintainability and its extensibility. And that was the issue that they had bringing the project to us. And to go through the features, we will explain it more in the demo. Right now we have the emerging situations. So let's say your company CEO gets canceled on Twitter, and you have to decide what is the best decision to do. This will raise or decrease your valuation. The next we have is the quarterly decisions. This is what really represents enterprise resource planner. And you go through different sectors such as how much units you want to produce, what price do you want, and this determines how much money your company makes. Next we have the financial summary. This will go through all your expenses and revenue, see how much money you've made, and you can use this to study and make better decisions future quarters. Next we have is the rankings. This is where you can see your valuation compared to other teams. The goal is to get the highest valuation so you can win. And lastly, we have the login page so you can log into the correct company. And now we will be talking about the design decisions and a technical stack with Gordon.
I'll be going over our technical solution and design decisions. So for our methodology, we use Agile and Scrum. We did 2-week-long sprints, and as such, it took an iterative approach to our development. Every beginning of each sprint, we planned out what we wanted to do, and in order to ensure our progress went smoothly, we met with our advisor and the sponsors on a weekly basis. In order to help facilitate this, we use GitHub tasks. For our development stack, we use Ruby on Rails, PostgreSQL, and Heroku. For our programming language, we did Ruby on Rails full stack. It worked well with Heroku and Postgre, and we chose it because our sponsor preferred it and it'd be easier to hand it off to them as when we finish our project, and as well as for its strong readability. PostgreSQL, nothing much to say here, is SQL-based database, and it works well with Ruby on Rails. For Heroku is a cloud computing service, but it is also a platform as a service, meaning we can handle the code and data, they'll handle the scaling, the servers, and the runtime environment. Is Git-based and is good for rapid prototyping for each branch. For testing, for what we did manually, we checked for our UI and made sure our information was being displayed correctly. For automated testing, we did automated testing for our calculations for our merging decisions and our quarterly decisions. And we tested this for at the end of each sprint, ensure everything works. And then I will hand off to Isaac to talk about our tree and go through our demo.
Yeah, so this is our main backend driver, and there's three main components to this. The first one being the general components, second one being the calculators, and the third one being smaller, simple retail or business type specific components. So the first one is the smaller business components. Looking at expenses here, that is an example. We have simple component, staff component, the plant capacity, and the production. These are all individual calculations, which is based on the quarterly decision input. And then those all add up into the expenses component, which is a sum of all of those components. And as you can see there, the expenses component is a calculator, as in it is either a weighted average or a sum component. And all of those other blue highlighted components are of that type. And that is our second one, which is the calculator component. And then we have the overall general components. These components are labeled at the top here. These are based on the accounting standards of assets plus liabilities equals stockholder equity. As we are calculating for valuation, stockholder equity is part of that, but then we also wanted to add the projected profit. Projected profit is essentially a projection decision of where your company is projected to land. We also used a board sentiment here to see how happy the board is, and then use that to multiply it by the projected profit in order to get the total valuation. And this is what the rankings are compared on. Another important information is the emerging situation. As that decision does affect what your end results are, we calculated it up here and then put it into the valuation right there. And now looking on to our demo, there are two main user types. The first being admin and the second one being a team. The first, the first one, the admin uses 5 main data tables. Simulations, simulation configurations, users, news articles, and emerging situations. Emerging situations are essentially a title, a scenario, and the different options. Few things that we had to do for this is adding multiple options and multiple different outputs for those options. And these will be displayed on the team side in the emerging situation. And then we also linked the news article to it, as it is a one-to-one relationship there. And then the news articles are also stored in a different data table. Another important data table is the simulation configurations. This is also very important. And one thing that we added to this is the sub description. Since this is the main driver and the main calculation based on the user's input, we wanted to make sure that the admin knew exactly what they were changing. And since they don't change this very often, it's very important that they knew exactly what they were changing. And the last data table is the simulations. This is where they create different simulations based on the different weeks that they're in and adding different financial quarters. These are financial quarters based off of a company. So every 3 months is one financial quarter, and then there's 4 per year. And now we will move on to the team side with Mon.
So now on the team side, this is where the team student learn how to create and run a business in real life. So first, they will choose a pricing strategy, and based on the pricing strategy they choose, it's going to have a different calculation. So for now, we're going to choose standard, and then they will name the company. And here is the dashboard where they can see some of the key financial metrics like business valuation, stock price, etc. And they can also see the chart to track the performance throughout the quarter. And team has two main tasks is emerging situation and quality decision. First is emerging situation, where each quarter team will receive a situation that they have to respond to, and they can do that with a new article. And next is quarterly decision, whether we have a list of business decisions that we have to input each quarter, and depends on their business type, this decision going to be different. And after they submit both emerging situation and quarterly decision, then the admin will advance the order, and then the student can view their ranking, financial summary, and historical data to know what they did last quarter and planning for the next quarter. After building all this, we took away some of the key lessons. Daily scrum and regular sponsor meeting keep up on track. Frequent communication over Teams and SNS prevent misunderstanding. And we always make sure to have enough time to plan for the code review for every pull request. We also learn a lot about the financial standard. On technical side, we learn a lot about coding in Ruby on Rails and understand the MVC structure. We also work through some of the DNS issue, and we learn how to design the application into the strength of Ruby on Rails. So looking ahead, the next step is sponsor review and integration into Washington Business Week program and curriculum, and some of the additional feature can be added in the future, or printable market research, impersonate a team user in the admin side, and help tutorial and some of the UX improvement. To wrap up, we overhaul the old business simulation and accomplish our MVP, replicating all the functionality of the old simulation. The design is extensible, allowing more business type to be added in the future, and the code is readable and maintainable. And the most important part is already deployed into a production server. And last but not least is our sponsor or happy. That's it. So that is our project. Thank you for listening.
Now we're welcoming questions for the first few minutes.
Good afternoon. My name is Georgia Enrico. My question is about the emerging situations. My big concern is how that is calculated. Like, is it just a net positive or net negative thing where, oh, they got canceled on Twitter, or maybe they contributed to a charity? Like, is it based, or is the calculation for how emerging situations affect your code based on like the duration and intensity of the situation, or is it based on more of a human review?
I can answer this one. So, like Isaac showed earlier in the simulation configurations, if you want to open it up, you can actually pick which attribute you want it to affect, and you can customize it however value you want. So let's say the chair wants to make this specific situation so that if you were to get canceled on Twitter, let's say you just lose $20,000. So it is up to the executives to decide what they want, but it is highly customizable.
I just want to understand, is each company simulation completely isolated, or do they impact each other like in the marketplace?
Yeah, so they're completely isolated. The only thing that is replicated over the different ones is the simulation configurations, which is set based on the whole simulation.
Bunch of teams running in the same kind of environment, but in isolation from each other.
Yes, and then once the admin advances the quarter, all of those calculations are made. So you don't calculate each team's valuation individually, they're all calculated at one time.
We do have time for more questions. Yes, go for it.
What was your favorite part of working on this project?
I would say my favorite part was we went down to Aberdeen and watched the simulation in action. It was really cool to see how the students are actually really immersed and they're all huddled around that screen. Our sponsors said that they're huddled around the screen. We're like, yeah, how much can it really be? No, they actually are huddled around the screen and really involved. So it's really cool to see. Great.
Big hat.
Yeah.
Two more.
I will also add on and say that impact was probably the biggest one as well when we went out to Aberdeen and see the simulation get used. And the fact that this project is actually gonna make an impact on people and will actually be used for kids to learn about business is really meaningful to me.
Have one more question over here, and second one there.
So how did you go about choosing the emerging situations? Like, is there a list of what sort of inputs that you created to go with that? Or how do you feed those into the system? That's what I'm curious about.
Okay, yeah. So once again, like in the page you see here is customizable. So you click new right here, and then it will show the title, and you pick a scenario text. So whatever you want. I just keep using the Twitter canceling. That's the first thing that always comes to my mind.
Yeah.
And then you go to options, like I showed earlier, and then you pick what specific attribute you want it to affect.
Okay.
And that attribute will get into be part of the calculation and then spit out. It will affect the validation of the company.
And one thing to add on that is there was an old simulation. And so it was based in React and Python, and we were replicating that logic. And so all of that old data too, so for the title, scenario text, all of that will be copied over from that old simulation. So it's not like we're having to remake any scenarios. They're already there for us. They just need to be copied over.
Okay. One last question.
It's for my personal curiosity, but I think it's really cool that I saw that like with the MCADD, like numbers like the balance and the cost, so automatically calculates it. I was in Business Week 10 years ago, so we had like they gave us like printed out papers with just the law balance sheet and then I like write it and like erase it with the SESDC-TOOLKIT. But I saw that you guys have like you start off with like a strategy and like a lot of it is like through like you either drop down with the strategy each one. I was wondering if it's like, is it fully through like strategies or do you still have them kind of like raw like choice? Just like,
Yeah, so to go on that, so there's actually 3 different levels of this simulation. The first one was paper, the second one is the one that's currently being used, and then the third one is what we're making. And so one thing that we like to think of is the first one was basically paper, second one is the era of cloud computing, and this last one is AI, and that's why we involved it in our emergency situations. And so then the decisions on that, the decisions can be whatever number they want within reason. So there are limits, so you can't take $1 million loan. There is a cap on it. And then the simulation configurations are essentially what's multiplied by those quarterly decisions and then added up. And those are configurable by the admin.
Thank you so much. Now let's get our first master's in computer science team up here. Get all set up.
There's always something. Yes, exactly. They break their
They are wonderful. If you wanted to pass it that. Exactly, it's happened to the sponsor. All right, let's settle so that we can get our second team started on time. So we are here for our remote structural health monitoring web application. Please take it away.
Hello everyone, we're Team DeSimone. We're working on remote structural health monitoring web application. My name is Vincent.
My name is Brian.
This is Wendy.
And our sponsors are Jeff and Kurt from DeSimone, and our faculty advisor is Professor Darty, who's here today. And then so a little bit of background on DeSimone. They specialize in structural engineering and construction consulting. They're founded in New York City in 1969. And then so far, they've designed over 13,000 different projects in many different states and countries. And then they support clients from all over the world. And when they requested this project to our team, they had three major motivations. So first one was active safety. They wanted an application that they can utilize to understand like how building changes in the building could affect like occupancy in the building and different components like elevators and walls. And then the second motivation is early detection. They want to identify like subtle changes that is happening on the building, like due to many different factors like wind, earthquakes, and stuff like that. And data intelligence. So they want to turn their sensor readings into real-time data to do more faster and engineering like decisions. And so now the overview of the project. When we received the project, the current state was they had it on a legacy. It was a legacy desktop application, so it was only available for a single user, and only had a local access. And then this led to a lot of pain points, like it was hard to share with other engineers and clients, no real-time data visualization, and then no centralized storage for historical data. And so what they asked us to build is something more practical, address all these pain points, and also be able to post it on the web and have different level of access to like different types of users. And now Brian will talk about the main features and the newly designed system.
All right, thank you, Vincent. So for the main features of our platform, so we offer 5 core features that help users take control of building data. And the first feature is the live streaming dashboard, which lets users visualize the data as it updates in near real time. And then we have the historical summary dashboard, which compiles historical data and then it streams it to the dashboard for users to analyze trends. And then we also have the admin project management, which enables administrators to create new projects and manage existing projects. And we have the channel configuration, where users can create new channels, virtual channels, and filtered channels. And then the last is the math function customization, where users can define formulas that they use to compute derived measurements from the data. And then for our target system, as you can see, that is the system with the application deployed in cloud, with the main service in the center. And you can see the different users. We have engineers, and we have external clients who own the projects. And then we also have administrators who set up the projects. And they can access the service from different locations on different screens. And then we have Sensor Cloud, which streams the data. into the service, and then the data can be analyzed and then sent to storage. And for storage, we use a SQL database in blob storage. And that is the lower level diagram for our target system. As you can see, it's broken down into different components. We have the front end where user requests take place. And then we have the raw data service, which fetches data from sensor cloud, and then it stores it in the Redis cache. And then from there, we have the filtered channel processing, where users configure virtual channels, filtered channels or clean channels. And then it also fetches channel configurations from the database. Then we also have virtual channels, which are responsible for getting math functions, fetching math functions from Azure to process the derived measurements. And then the automated background job, which is responsible for updating the CSV file. We keep a CSV file for every project. And then it also compiles the historical data and streams it to the dashboard for visualization by users. And Homebrew will take one.
So I'll take on explaining the background job, because that's maybe seems too general, and I'll dive into two sections of its function. First one is a daily CSV update. So once per day, the background job will fetch the previous 24-hour data from the Sensor Cloud API. And with calculation, it will fetch all the active filter and the virtual channel and get the normalized metrics. And it will also append those data to the under the formatted title colon. And also with the write string, it will update the CSV file on the Azure blob storage. And then the next part is after we storage all the historical data, when there's a user request from the front end, the background job will first look into the project metadata like project name, project ID, and use that with the user request and find the related CSV file from the blob storage. And then we'll read it from stream. And also background job will calculate this data to get the historical data summary. And then it will visualize it and display it to the front end user. And then we will demo our system.
Okay, so here is our home page, and we'll first show from the project admin management page, and then coming back to our main dashboard and historical summary page. So if we go to admin view, it can bring you to a project management page. So here is where the admin can manage all the buildings. So here currently we have 2 active buildings, 125 Greenwich and 181 Fremont. So let's say the admin want to add a new project, they can just come here, and then let's say I'm just doing a demo right now. You have to give in the API key and the device ID. The admin should know this. And once you have that, the system would be able to discover the available sensors. So right now we have 4 sensors available. And right now, let's say I want to pick sensor 6419. And let's say I want to pick just the first 2 channel, north and east, and then hit confirm. And now it would bring you to a raw channel configuration page. I will pass it to Yun-san to explain this part.
Yeah, so when it leads to raw channel configuration page, so we can choose the raw channels that we chose when we create the project. So we have the north and east, so we can just choose north and then give it a descriptive name. And then there are 3 different filter types. There's bandpass, high pass, low pass. So we'll apply bandpass and give it a lower cutoff frequency and upper cutoff frequency. And then save the channel. And then this would be the clean channels. So raw channel will have a like filtered. So it'll be more. It could be used to get more grab more data. And then you can also activate it and deactivate it. And you can also delete the channel if you would like. And then Brian will demo the virtual channel computation.
All right, thank you, Yun-san. So just like Yun-san demoed setting up a road channel. We can also configure a virtual channel for a project. And for a virtual channel, you need a math function. So you have a math function drop down where you can choose which kind of math function you want to use to configure your virtual channel. And if it doesn't exist and you want a new math function, you can add a new one. All you need is a math function deployed to Azure. And then you need the URL from Azure. Then you paste it right there. And then the function name. And then you can register a math function. And then it will show up in this drop down, and then you can select it. Say we select resultant acceleration, and then it will bring you to this form. The form is dynamic and it's specific for every math function. As you can see, for resultant acceleration, you only need 2 channels. But for if you can go back to say root mean square, the form is dynamic. As you can see, it needs 1 channel and then a constant. So we are going to use root mean square, and then all you need is the name for your channel. And then select a channel from a filtered channel. And then the samples needed for a constant. And once you confirm that, the channel will be saved in the database and it will appear in under the project. And yeah.
Yep, so once we are done with configuring the channels, and we can see this new project is created in here. Right now, because we didn't upload the new image, so it would just show a placeholder image right now. But you can always upload the image later in the admin portal. Once you go in here, you should be able to see 2 channels that we created earlier. So by default, it will just show like these 2 channels you created. If you want to customize it, we can go to admin view and then you can customize it. So let's say you want to just display 1 graph, you can do that. But for this demo, I want to display 2 graphs. But maybe I want to change the position of the graph. You can always switch this up. So let's say I want to switch this here and switch this here. You can do that, and you can also resize your graph. Let's say I just want this kind of size, and then I want to save this. You can just give it a name. Let's say layout 1, save it, and then it would save in the database. So this gives you like a chance to save multiple layout, and then you can always change this as you like. And if you go back to customer view, it should show this to every other customers. And yeah, you can also pause the graph, and then there is like different graph settings. So you can download this graph as an image, and you can like zoom in the graph, zoom out the graph, and there's like you can play around with the graph. And yeah, I would pass it to Yunsan to demo the historical summary page.
Yeah, and for the historical dashboard, basically, that's what I talked about the background job due. So we will have basically by default 2 types of graphs. One is scatter point, one is bar chart. And we can also go to the admin view and customize it. So basically you can customize 2 things. First one is a grid arrangement. If you want a larger view of each graph, you can choose the second one. And if you apply it, you can see the larger view of each graph. And also if you want to change the channels and the number of channels up to 3, you can just change that here, and you can also like switch the chart type here. And also as we did in main dashboard after setting up, and you can just give it a name and save the layout, and you can always go to the save the layout list and choose one. And then after you like existing the project and re-enter it, you can always see the latest saved layout here. And yeah, and that's basically what we have for demo, and we'll go back to our presentation.
Yep, so for our testing, for backend, we're using PyTest because most of our backend code is written in Python. And right now we have a 326 of total tests. We have unit tests focusing on the core logic functions and the database stuff. And we have integration tests, mainly focusing on the API endpoints because we want to make sure like we are getting the data correctly and we're handling that correctly. And these tests are all running automated in the GitHub Actions, meaning that if someone pushes some new changes, it doesn't break our current system. And for front-end UI testing, we are using Selenium. On the right, you can see a video of like the UI test running by itself. It's like navigating by itself. And we have this test focusing on all the main features, except for like the admin project management page flow. And for the front-end testing, we are using headless Chrome in GitHub Action because it's faster. Next, I will pass to you.
Yeah, and for what we learned from this project, I should talk about the two challenges we encountered. The first one is there's always evolving new requirements from our stakeholders, and that will be conflict with our initial project plan. And to deal with that, we need to always discussion with our stakeholders to rearrange our priority order in our backlog so we can make sure all the high priority items will be included in our MVP scope. And the second challenge is that there's always like external dependencies that are out of our control. And this can block our development of features. So we're trying to using like mocking, find a way bypassing them so we will not be like blocked by them. And also in our communication with our stakeholders, we learned that it would be better if we can bring the potential solution or even like a proof of concept to them. So it will easier for them to give us direct feedback, and that will improve our efficiency of communication. And that's what we have for today's presentation. Thank you.
Time for a couple of questions. Yes, back there.
Thanks for a really interesting presentation. Can you describe the different ways that you use AI to support your work on this project?
Yeah, of course. And first of all, when we wrote our documents, we will just draft it and just give the draft to the AI and help us to partition it. And sometimes when we have like architecture design, we will just have this initial plan, and we will just show this to AI and to parse it and to see if there's any like potential problems or like is there anything we can improve it. And also if sometimes there's like small features, we think, okay, we have this plan, but we know how to do it, but it's just too simple. We just give the plan to the AI and we generate this very little code snippet for us.
Yeah, and to add on, so when we first got the project, we didn't have any like background information. Like we didn't know about like what those channels mean, like what those sensors and then all the data that stream. So AI really helped us just to be more efficient and understand it better.
Really like the presentation, the graphs and whatnot, the flexibility you provide through that. Question I had on the data acquisition side of the house. Are you getting data pushed from the sensors on a constant basis, once a second, once every 5 seconds, or are you getting deltas pushed to you from the sensors? And if the latter, why wouldn't we just keep the thing running all the time?
I think it's like a real data point and each minimum second, and it's not directly from the sensor. I think it's the sensor card is like a data platform for all the sensors, so it will calculate all the sensor data, and then we will call the API and get the data from the sensor cloud.
Okay.
Yeah, and because we need to use the API calls, and our sponsors don't want to cost too much, so like we need to like use a cache. So like 1 hour, we fetch 1 hour before, and then we just use this sliding window to show like near real time streaming in 10 minutes. Yeah.
Financial.
Yeah, exactly. Always budget.
Thank you so much. That's all we have. But congratulations. Start setting up. Preparing for the session. When you're ready.
So hi everyone, we're the George Pocock Foundation team. My name is Nardos and I'm here with Kong, Giorgio, and Ton, and our faculty advisor, Professor Mickey, and our sponsor, Patrick. So to talk a little bit about our sponsors, the George Pocock Foundation team is a non-profit organization that has been established in 1984. Their main mission is to introduce rowing to the youth. They have been serving about 55,000 people, young people, each year, and they provide financial aids and scholarship to their students, and they also promote inclusion and accessibility. So the George Pocock Foundation team, the organization, as they grew, handling program management, the program, the data's registrations and reports became difficult. So they relied heavily on manual processes, and they used spreadsheets, and data was saved in different places. And due to this, it became time-consuming and difficult, and reporting became difficult. So our solution was we created more of like a centralized system where all the programs, the participants, the programs, the reports, and the participants are all in one place, so that things could be easier to handle and manage. So I'm gonna pass the next part to Kong.
All right, thank you. So before we go into our key features, I will briefly introduce our technology stack. So we choose the Next.js for our front-end framework as it's offer a lot of richest building features. So we use us to integrate it with our backend frameworks. So that will be the Next.js to handle any business logic, dynamic connection, and many like background tasks for those one. We also choose the Firebase for our authentication handle because we don't want to risky handle those things because to maintenance that's really take a lot of work and time to make sure it's run smoothly. And we're also using the Firestore database from the Firebase. That is NoSQL, so it's pretty also easy to integrate to our system. We also have the Swagger for API documentation. So if we have a new person on our team, they just go there and read for the API encryption, an example how to use that one. And by the end of the project for the deployment, we choose the Google Cloud to deploy them. We use the Google Cloud Run services, will be like a serverless to deploy our front end and back end. The way to deploy is also easy to just run the code. First time set up and run the code, just will deploy on the cloud so user can access us everywhere. So let's go to our key features. So we gonna have 5 key features for this project. So the first one also talk about the authentication. But before develop the this system, we are decided to have 2 separate portal, one for the user and one for the admin. For the user, like a participant portal, we have 2 profiles, the guardian and the dependent. For the guardian, they can manage like 0 or many dependent profile, and when they register for a program, they choose which dependent will participate into that program and manage a lot of dependent information. While the dependent profile, they have limits of features. We have not yet fully implemented that, but the key idea of that they can log in, see their information, update it, and view their registration status. And there are another portal is the staff portal. So that's what we use for the staff for their daily tasks to do like manage program, everything from the organization. So the next feature is the pre-registration profile. This is the participant portal. So when the guardian first time log into the portal, they will asked to be put to fill in the basic information like their name, address, phone number, and how they know about the organization. After that, if they complete the profile, and the system will navigate them to the dashboard. From there, they can create and manage the dependent. So they can select the dependent for the registration. The third features is program creation. This one will belong to the admin portal. So the staff can create the program, put all the program information, create the question, question. So when a guardian registers for program, they need to fill out all the question that's created by staff. And if that field is not required, they can pass it. And also staff have the features to create like a requirement. This will be like a predefined rule. So if the applicants met all the requirement, they will automatically accept it to the program. Otherwise, they will be put on the waiting list. So staff can look at that later and decide the next step. The next one will be the registration. So this one, the flow will be back and forth from the staff and the participant. And for now, after the staff publish the program, the participant can go there. The guardian read all the program information. If they interest to that the program, they just select sign up and then choose which dependent will sign up for that program and fill out all the required question. And the last one will be the admin portal. So as I mentioned, that will be like the staff daily task. They can manage the program, view the roster list, view the dependents and the guardian list. They can create program and also like manage the staff information and give the permission. Let's go to our testing approach. So for this project, we have like three type of testing. The first one will be manually. So after we develop one feature, we will test it manually, see like if the UI met our expectation, if it's run correctly. And the second one is the unit test. So we'll test all the components. And we also integrate this to the GitHub action to make a regression test. So every time our team member puts the code to GitHub, this will run the test to make sure like the new change will not break the old code. And the last one is end-to-end testing. Basically, this is our UI automated test. It took a lot of time, so we just try to focus on the most important one, like sign in, sign up from the users, the registration flows, and some basic from the admin portal. So let's go. I will hand this off to Joshua to start our demo.
To start out, we will show up our system flow. So this is for guardians of youth rowers. This is the flow for creating an account. So here you can see that we create an account, we get sent the verification email. This is my email, and here we got verification. So we're filling out the form for account creation. We get the system message was created, and we get sent to the Guardian portal. And here we're creating, this is the actual youth rower participant. So the guardians of youth rowers can create profiles for the youth rowers so they can sign up for rowing programs. Here's the emergency contact and phone number. And there we can see that youth rower John Doe is created. And when we create edit, click edit, we can edit the information as well. So for the live demo, on the left here, we have the Guardian Rower, Youth Rower Guardian portal, and on the right, we have the staff dashboard. So here on the staff side, the staff can do a variety of features, but the main feature here is program creation, where we want to create rowing programs. So here I'll create a test. Program. The description is test. optional capacity we can set. And we can add an info section where we can add, say, how this is a test program for hours. And there are a variety of options for adding info section. I got a question here. Yeah, so you can set tests, how many years, and number. You can put a number here, but these are a variety of options that we have to save the program. And on the user side, we've made John Doe on the view thrower, so we can go to programs, get test programs, what I just made, selects on John Doe, register, and on registrations, we can see that they are waitlisted for the program. That is our demo. Pass on to Twan.
So as we have seen the demo, I would like to take a step back and walk through the journey of our project. So when we first met with our sponsors, the goal was not just simply building a website, but more like try to brainstorm and figure out a way to help them improve the organizational workflow. So as Nodos has presented, that initially our sponsors workflow will mainly involve manual validations and then manual record for the data. So with our platform, we're able to aggregate everything into one platform where we have like able to manage the program, help them to for users registrations, and then keeping store of the users data. As of now, the project come to completions and we have completed the handoff to our sponsors. We are proud that we're able to like deploy this into the productions and it's in a current testing phase. For the future, we were also thinking of like expansion for reporting, since every information and data is living inside one database. It's create incentives that we can build a report and decision making for organizations in the futures. For our takeaway, throughout this project, we realized that the integration step is probably one of the hardest steps where we have to invest a lot of effort to ensure that everything, every component, every features working together and working seamlessly. Second of all is where the scope is also matters. Initially, we also planning and thinking of a lot of cool ideas, such as what if we also allow volunteers to sign up as well? What if we also allow the platform to manage donors information as well? But then we also need to focus on the core aspect of the organization is that Joe's Pocock want to create this program to help the youth to sign up and to enjoy the rowing sport. So that is what our platform was focused on, to allow the organizations to create this program for users to sign up and for the staff to easily access their data. Next is when testing. Testing is probably one of the major things that we also planning from the beginning, because each features, if we are not properly tested, they will compound all this error into later state of the project and could create a cascade failures. So for each feature we build, we also test them thoroughly, and we are proud that testing also help us building the confidence during the development as well as the handoff. And last but not least is that throughout this project, we also learned that software development is not just building technical features, but also what we can give, what value can we give to our sponsors, to our clients, and what impact can we help with the communities.
Throughout this project, I would like to thank you, George Pocock Rolling Foundation for sponsoring, and I would like to thank you, faculty advisors, and everybody who believe in the team helping us achieve this success. Thank you so much, and we are ready for questions.
What were some of the technical challenges that were the most difficult for you guys?
Not sure was for us like is you want to share?
I think one of the things we have to spend a lot of time thinking of is authentication and security, because we are working with real users' data, and they also teenagers, so we also have to take extra careful, like how we protected their informations.
Had you developed a web application, a modern web application like this before this? And if not, how did you learn all of the variety of things that you really have to do to put that all together?
So basically, I have some experience on building like full stack from like also have the mobile one, but like so because I have experience before to build a web app, so I from the start I know like what I need to build more like a skeleton or scaffolders to have it like maybe like abstract class for that one. So in the next step, they just need to like write a class of that one, put them together and make it run. So I think I want to add on like the most challenging we have like from the beginning is like build a scaffolder, because if it's already strong, we just need to add on more. So that would be very easy for us.
Well, I don't really have experience with something. I built like basic web apps. Kong basically put a skeleton for us at the start. And I think some of the learning process I went through was like, if Kong did something, I would copy the code, like 3 lines. I go to the AI, I'd be like, please explain to me, what is this? And I'd look it over. Yeah, it's a long process, but eventually it kind of like came together at the end. So I think that was a good learning experience. Pretty painful.
Does it work? Yeah. I would say the first quarter was the documentation parts. I think that was the longest for me, because building up, I did have experience before building up the web designs and everything, but the documentation was important because maybe sometimes it might get changed like in the middle way. And I think I would say that was the documentation.
I have a few internship experience, so I did usually come in the middle of the project. So the scaffolding already exists before. I just come in and building features, testing, like tiny thing like that. But yeah, I think like Kong is a major like scaffolding for the projects, and that's where our team success comes from.
Okay. Oh, we have one more question. One more question. We do have that.
Did you guys find any competitors to an application like this in your initial research? And if so, what sets you guys aside from it?
Actually, we still don't find anyone, but basically we built this from sponsor needs. So we just ask them like how they want, like we are deeply understand their pain point, like they have like data spread out everywhere. A program can have like one person, but like the information is duplicated for every program they register. So our solution for that is just try to solve their reduce their manual works and then try to centralize all the data in one place. So for the next step, they can just generate the report from the data that we have. That's like give them more time to do our works. But for the competitors, we don't think we have anyone. But like yeah, we just build that on sponsor need for their work.
Well, thank you so much.
Hello, everyone. Do you hear me? All right, awesome. We are team MSCS 2603, TPM fuzzing team sponsored by Google. I am Nabiu. Here with me is Gigi, Davis, and Timothy. And today we're going to talk about, like I said, TPM fuzzing. So let me ask you a question. So your devices right now, how do you know that they're safe or haven't been tampered with? How do you know that somebody in the middle of the night last night didn't add some malicious code? You know, you don't, you just trust that the software and the hardware will work together as you expect. Now think about medical devices that run patient records or banking systems running wire transfers. So those devices don't get automatically trusted. They have to prove it. And that trust or that verification is done by something called the Trusted Platform Module or the TPM. All right, so the TPM is a security chip that's embedded in most modern devices. Its job is to make sure that the device does not get tampered with or modified when it's booted up. So there are multiple types of TPMs. They're everywhere. So most laptops, Windows laptops that were made in the past 10 years, they probably have a TPM. Corporate servers, medical devices, smart devices, corporate devices, and just cloud infrastructure, they all contain TPMs. So it's very important to make sure that they work as expected. What happens if there's a flaw in TPM? What happens? Well, if an attacker gets access to a TPM, they don't need to guess your password or know or get you to click a link. They're past all that. They have access, the most basic type of access, right? So what happens? What that person can do is that they have now the encryption keys to your hard drive. They have that verification when you try to connect to a corporate network. TPM proves that. So now that attacker can just pretend like they're you. So that's why it's so important to test the TPM. Well, think about it like a security guard that has access to every room in a building. That guard is responsible for making sure those keys and those keyholes don't get tampered with or modified. But if somebody pretends and is able to pretend like they're the security guard, and that's a big problem. And that's something we want to test.
Yeah, so the next question is, how do we test TPM? TPM is a small component, but it is very complex. To give you an idea, it has 164 different requests or commands that you can use to do something like checking device integrity or like encryption, decryption, and a lot of other things. The problem here is that the commands do not only happen one at a time. It can be used in many different orders, and even some of the commands require setup from other commands for it to be successful. On top of that, there's not only just a single TPM implementation, there are a lot of them, even though all of them need to follow the same standard. So testing all of them, or like the actual test case can be very large and just unrealistic to test it manually. And that is what we are building for our capstone project, a testing framework for TPM implementations. To do this, we use a testing method called fuzzing. Fuzzing here is just an automated testing that can generate and mutates many different test inputs, send it to TPM implementation, and then see how it responds. It is really useful here to use fuzzing because it's not only generating or like testing the normal cases, it's also testing unexpected, random, and unusual inputs that the developer might not think about before. So these interesting inputs that can cause crashes, errors, or slow responses then are safe and can be used later on when you want to run the framework again to check for problems inside TPM implementations. In our project, we use a specific kind of fuzzing called coverage-guided fuzzing. The main idea here is still the same. So we take inputs, we mutate them, send it to TPM implementation, see how it responds, and then save the interesting inputs. But for coverage-guided fuzzing, it expands on the idea of interesting inputs. An input can also be interesting if it reaches a new path inside the code base. So this is kind of important for TPM because most of the hard-to-test scenarios for TPM are hidden deep inside the implementation. If we don't take into account the inputs that can reach new code path, we essentially going to just testing the same shallow path over and over again. And with coverage-guided fuzzing, we can use these interesting inputs as checkpoints so that we can go deeper and deeper into the implementation as we mutate it further. Based on that, this is what our framework looks like. It has three main parts: the inputs, the fuzzer, and the TPM reference with patch. For inputs, they are just the starting examples for our fuzzer. It consists of initial inputs that we provide and also the saved interesting inputs. Then the fuzzer takes those inputs, use them, validates them, mutates them, send it to TPM reference, and all the flow of fuzzing that I've talked about before. Plus, we have the TPM reference with patch. The TPM reference here is just the current TPM implementation that we are testing. And the patch is just some small code changes to make sure that the TPM reference is compatible with our fuzz.
Oh yeah, so now we know how the framework tests the TPM. I will go from the start, the input. We can see that we got two kinds of different input. One is initial input and the other one is saved input from previous round, which can increase our coverage, or which called is interesting input. Yeah, now we know we have different inputs, but how we send that input to the TPM fuzzer. We can see that or without the initial input, we can think about in the middle there is a dot over there. We can think about is as the TPM code base. We can see that without initial input, the input could be very scattered and it could be rejected very early. But with the initial input, we can see the second picture. Almost all of them are targeted inside the code base. So that's why the initial input are so important for us. Yeah, so now we need to send the input to the TPM. We are using two kind of different fuzzing approaches. The first one is batch array fuzzing, and second one is called structured aware fuzzing. Yeah, for the first batch array fuzzing is very obvious. We are feed a lot of batch array, like at the left, we can see from it. It's basically some batch array, some random number. They are fast and they can like randomly mutate it and generate some very strange and unexpected edge cases. But there are also some cons because it's very hard for us human beings to know like different command means what. And sometimes it can run the whole command because they can mutate some authentication parts in the input. So that's why we keep the second approach. We can see from here, it's very easy for us human beings to know different command means what. So they are very structured, valid command, and easy for us to understand and read. But some cons about it is it requires some prerequisite knowledge about it, and also we need to makes the fuzzer knows different field means what. And also, since the mutation is targeted, so it could mean some unexpected edge cases. Yeah.
Cool. So with that little bit of introduction, I'd like to cover through how we actually measured our success and our progress throughout the project. So as mentioned, we use coverage-guided fuzzing to kind of test out the TPM. So one of the things is that provides us metrics on how much of the code base we've actually covered. So that comes in various forms, and we've charted it here on the graph that you see on the slide. So I'm sorry that it's a bit hard to read from far there, but I'll just mention the numbers. So as of our latest run, it's around 80%. this graph is from May, the end of May, where we were at 67% of the TPM code base. And just a few other points that I'd like to cover on our progress so far. As previously mentioned, we were able to implement two types of fuzzing strategies. One was byte level, and the other one was more command aware or more structure aware fuzzing. The second one, which wasn't really showcased in this slides as much, is that we've actually automated the process of running this fuzzer. We do have this running on a weekly basis on the cloud, discovering new cases, discovering new inputs and testing the TPM for more and more things. As previously mentioned, I think at the time of making the slide, 70%, now we're at 80%, at least when it comes to line coverage, which is one aspect. The other thing is that we've been able to successfully test a TPM implementation that is part of the standard that is provided by the backing organization. And we have our fuzzer kind of running on that reference implementation of a TPM. So this is a bit of a divisive topic we weren't going to talk too much about, but initially this project did not include any kind of AI integration, but towards the end we did attempt to use the AI a bit, and we did notice that it was able to leverage our existing work to generate better initial seed inputs. So that's a bit of work that could be explored in the future, just something that we wanted to mention. And I think it jumped the coverage to around 82% as of testing last time. So with that, what's really left in the project? There's no way we can say that this is done. There's still a lot of work to do. One thing is that we tested this on the provided standard reference implementation, but this isn't real world scenario. That is a standard specification that was provided. It's not a true TPM that is being used by a corporate, entity. So we would like in the future to at least test it with real world scenarios, have actual developers that work with TPMs use it and give us feedback. The second is improve more structure aware fuzzing. It's not at the best point. We did start it this quarter, so we just have the groundwork set, but there's a lot more to improve. The last is we're releasing this open to the public, so you here, if you're interested, can actually access it right now and see what the code base is like and use it a bit. But it is also being reviewed by the organization that publishes the standard, which is the Trusted Computing Group at the moment. On that note, we have talked quite a lot, and I hope you have questions. And yeah, we're open to any questions. Thank you so much for listening. Any question?
Oh. So, does this work? Hello, here we go. So you've got just a small improvement from using AI. Is that what I heard, 80 to 82%? And my question from that is, what changed? Like, how did AI help? And
Right.
did you find any actual defects?
Okay. So so you kind of use AI when you already have like a stable framework, I guess. So I think using AI with that, it's kind of helpful for us because AI did a lot of the groundwork to create the initial inputs that we can use into the fuzzer itself or the framework. And so yeah, we actually found at least a bug that we also mentioned to our sponsor. And I'm not too sure if you can share that right now, but at least, yeah, they're trying to check it out.
Maybe not the details.
Yes.
Also, just to clarify, it was a jump from 65 to 80.
Yeah, with AI. And for context, we did this project for like 9 months, right? Or at least 6 months. But with AI, we able to make that jump from like 67 until like to 80% within like 2 days. It's quite a lot.
So for your test metric, you're focusing on code coverage, and it was unclear to me how much access you would have to the code for TPMs in general. Is that an issue for future development?
So at the moment, access to it is mostly provided in like a specific language, which is usually C++. So it's not that hard to actually access the actual software running on the physical chip. It's a bit easy to access from a developer standpoint. From the general public, maybe just the specification. But all these developers have relative easy access, and our framework integrates easily with the widely supported one. I'm sorry, this mic was off the entire time, but I hope you can hear me. Thank you. I hope that answered the question.
Any other questions?
Were there any other testing methods other than the fuzzing that were explored? Because I'm not very familiar with the parameters or what that really entails.
Yeah, so each implementation has their own testing frameworks, like units. They have their own. Specifically, this project was about fuzz testing TPM. So that's the whole point. Yep.
Cool. Oh. I think we don't.
Yeah, so, what I guess I've got a couple of questions. The first question, I guess, is I'm not really understanding why you would need access to the source code running in the TPM chip, because all you're doing is sending inputs and to the TPM chip and getting outputs and then sending inputs again and so on. Do you really need the access? Do you actually need the source code in running in the TPM chip?
I can take this one. Specifically, we do need access for a number of things. The first one is that we need to be able to actually have metrics to tell how far in the TPM source code we've actually explored with our inputs. So that's one of the primary reasons we need the source code, because there's no true way to get those metrics without knowing the source code. If it's in a black box, we don't know how many lines, what was executed, and a number of things. The second aspect is that we kind of are not just sending inputs and watching the output, whereas we don't care about the output in a sense. We just care that it is successful, that nothing crashed, and it didn't do anything weird during the processing. So the output isn't as important. We actually just monitor the TPM to see how are you behaving on the computer or on the chip. Are you using memory and not freeing it, which is a very big problem in computing? Or are you doing something that in that language is undefined? It's like walking through that wall if wall physics was not a thing in real world. God knows what would happen, or in games or something. So we're just making sure this random cases do not occur.
Right. The thing about that is the goal there is looking for proper operation. And what I'm kind of interested in this project is, have you thought about bad actors using the work to look specifically for improper operation? They don't need to see the source code for that. All they need to do is crash the TPM chip and then they know they've got something.
Yes, and this is one of the big things, and this is kind of why we were alluding to we are not able to say what bug we found. We're not, so it's kind of a cat and mouse kind of game with security, I believe. So it's most fuzzers are usually open to the public. There is some tooling that some, like our sponsor, uses that does this kind of fuzzing in a wide scale than what we're doing. So it's kind of up to people who use these tools to be kind-hearted or good-natured and not use it badly. So I don't really have an answer on how we can tackle that at the moment. We're just providing it so that the good people can
Perhaps
use
the bad actors, when they do use the tool and find a hole, they'll stimulate the company that released the TPM chip to actually release a firmware update for it.
Yes.
That seems to be the way it works.
And we're hoping these corporations that do build TPMs actively run our software.
Yeah.
Okay, our time limit is 20 minutes. We already passed that 20 minutes, but I think one last question.
Yeah. So, just building on the previous question a bit, recently the Xbox One was hacked,
after hacker inject low voltage into the security ROM, have you tried to FUZZER on the extreme condition like that?
So we haven't tried like physical low voltage and stuff like that, but we've tried process wise. So the TPM has some process specific commands, like starting up, coming back down. It saves some things in memory, in its own memory, stuff like that. So we've tried like normal behavior kind of test cases. And the FUZZER has also tried random other test cases, starting from the TPM being awake. So we haven't really tested any low voltage physical exploits of the TPM.
That would be like hardware test.
Even it can be like the future works for our projects. But yeah.
All right, thank you very much. Next team is MSCS 2064. Also, it's the athletic performance science.
Test. Hello.
Yes.
And then stay in the meeting after the sit down.
Okay, hi everyone, welcome to Project State. This is Team 4 of MSCS 2026, and this is our project entitled Performance Science Intelligence Hub, which is sponsored by CRAU Athletics Department. First off, I'm going to start by introducing the team. I'm Nao.
I'm John.
And next up, I would like to introduce our faculty advisor, Dr. Shabuk Samavi, and our sponsor liaisons, Dr. Mataki and Dr. Kyle DeRoja. And we'd like to thank both our faculty advisor and sponsors for their support, guides, commitments, and for the success of this project going smoothly. And now to begin with, I'm going to jump off to what the challenge is in the first place and what the problem in hand is. So the SESDC department uses various sports technologies to measure and record athletes' in-game or training performance data. And so these various sports technologies have their own different platforms. And currently there are 3 devices that are being used. And now having these different various platforms creates an issue when coaches or other staff of the athletics department try to get insights from combining those different data coming from the different platforms. And also these different platforms, they only give us their own custom data visualization, which limits us in not to create any type of new visualizations or insight we'll get by performing different kind of calculations or different performance data. Basically, this is the main issue, and now I would like to go through what data solution to solve or tackle this problem is. And this is where the performance science intelligence hub comes into picture. So the PSI hub is a cloud-native centralized web platform. And the main goal of this is to centralize all those different data coming from the different platforms into one centralized system. And this allows a lot of opportunities to perform or do calculations on those data to gain actionable insights for the staff or coaches. And this is by providing different type of views for team level or specific to an athlete and seeing their data coming from the different sports technologies. And the PSI has different user roles where an athlete can see their own data, and also coaches can be able to access team level data for athletes and the team's performance overall. And the PSI, the way we developed this is in a way that is scalable. So not only current existing technologies, but it's also open to adoption of new technologies that will be used by the SESDC departments. Now that I've said this, Joanne will walk you through the high-level architecture of our system.
So here's a high-level overview of our application. On the left, we have our external data vendors. Our application pools bring all the data into a centralized database of PostgreSQL. This is where all the team information, performance data, and profiles are stored in a structured and reliable way. So on the right, our application itself is hosted through Railway. The Django backend sits between the database and the web UI. So its job is to ingest the data, organize the data, and apply access rules. And finally, the React UI is what end users interact with. It turns stored data into visualization that are easier to use and understand. Also, our technology choices are centered around the business needs. We use Django for our backend because it's fast to build with, it's easy to read, and it's well suited for new projects like ours because the requirement changes very frequently. Also, because Django is Python-based, it gives us a strong path towards future integrations of machine learning features. So for React, it's a very widely adopted front-end framework. It's especially good for building interactive dashboards, reusable UI components. Also has a very large developer ecosystem that makes future development a lot easier. And finally, the PostgreSQL is also a very mature and widely used relational database. since sports data is very sensitive, Postgres is a good choice because it provides structured storage, access control, strong consistency, low-level security, etc. And finally, our infrastructure choice is Looker-based and Railway. So this combination keeps the deployment simple and let our teams move quickly without having managing too much infra settings. So how do we store all this data efficiently? So at the center of the system, which is on the right of the page, there are athlete profiles. These profiles can be connected to team information, access permission, performance data, etc. So on the top left, users are connected to teams through user team access. This is where the system decides which users should be able to view which teams. And then teams are connected back to athletes through team roster link. This allows many-to-many relationship between athletes and teams. And on the bottom left, we have our tables for the external data vendors. So each vendor bringing a different shape of performance data, which are later connected to athlete profile using the external IDs from each data vendor. So the main idea is that the athlete profile as a hub, team organized athletes, user get access through teams, and the external system feed the data back into each athlete's profile. Next, we'll have Ian to go over the system in detail.
So to start with, here's a system context diagram to show how our system interacts with external systems and actors. Firstly, we have the sports data vendor where this is where we're getting all the data from, all the different sports vendors. And from there, we have the student athlete who can go in and look at their own personal data. The coaches can go in as well, and they'll see the data for their respective teams. Lastly, we have the administrator who not only has all the permissions as above, but also can manage the rosters as well. So we're going to go over the 5 main features of this project. Firstly, we have automated data ingestion. So we have a system that automatically pulls from all the data vendors every 5 minutes, and they look for new data. From there, we also want to show the data in a way that's easy to understand. So we have charts and graphs for data visualization. And since this is specific athlete data, we want to make sure that nobody sees what they're not supposed to see. So we have a role-specific access. So athletes can see their own data, and coaches can only see the teams they're in charge of. And to make this seamless, we made it so you can sign in with your Seattle U account. So once you have an SSO sign in, it'll look for an existing account that matches your SUID and your email. But if you don't have one, it'll create one for you. And lastly, we have a team roster management system. So the administrators can not only move athletes around, they can also assign coaches to different teams. And also, when the new system comes in, we created a batch register system. So the administrators can register multiple units incidents at the same time. So here's an example of the role-based user flow. So when you reach our website, typically it will ask you to sign in. And once you sign in, it'll check for your scope. So you'll either be a coach, admin, or athlete. Coaches will go to the coaches dashboard where they can see all the different teams they're in charge of. Athletes will check to see if they're onboarded and matched to a specific athlete. And if they are, you're able to see that data. We chose 2 ways to match the athlete to the user. We chose that you have to have a matching Seattle UID and email to make sure the athlete doesn't see the wrong athlete data. And lastly, we have the admin dashboard, where you have all the same permissions as above, except as what stated before, you can manage the roster.
Yeah, here's our project timeline. For this project, we are using Agile methodology. We have weekly meetings with our sponsors where we demo our progress, collect valuable feedbacks, and then address them in the next week's sprint. Here I want to give a shout out to our sponsors because of their commitment, domain expertise, and guidance to help us to prioritize data security. I remember there are so many times that during meetings they mentioned the importance of avoiding accidental unauthorized data access. And that's why we use this role-based access control to permission as our technical solution. We also plan monthly releases. During October, we started requirement gathering and familiarize ourselves with different data vendor technologies. In November, we started data centralization. In February, we delivered coach dashboard with raw data. In March, we delivered athlete dashboard with graphs to help with visualization. In April, we added role-based access control into our system. In May, we integrated with Seattle University SSO. And in June, we delivered the MVP and prepared for handoff. So how do we ensure our code quality? Here, so in the backend, we have 544 test cases, including unit tests and component tests. And as you can see, we have them 100% passed, offering us code coverage of 95%. Meanwhile, in the front end, we also have 11 UI tests to cover the main avenues. Next, we're going to show you a live demo of application.
So today we're going to demo 2 user roles. I'll be first logged in as an admin using my pre-existing username and password. So our definition for the administrator is not only the system admin, I'm also the admin for the whole org, which means I'll have access to organizational-wide performance data. So for example, all the teams in Seattle U Athletics are available to me right here. And I also have access to team-level performance metrics where I can filter them here and decide which teams I want to view. So as a work admin, I also have access to all the athletes within Seattle U Athletic Department, accessible through athlete roster. So it's worth mentioning that we put the system into demo mode so that all the personal information is matched, but I could query athlete by their name or email. And here I can access their performance data in a visual way, but I could also access their performance data in the numerical raw data form, accessible through data sources. And the other user role that we want to demo is a coach role.
So I'm going to demonstrate our sign-in system here. So currently, this account I'm logged into is in charge of only one club, which is the API testing club.
So that's why my job today as an admin is to assign new teams for our new hired coach, which is accessible through admin panel located right here. So when I go into admin page, I have access to all the current users in the system. So, and they're grouped by their access permissions, for example, system admin, team scope user, and no team memberships. So I'll find Ian right here. Right now, he is assigned as conditioning coach of API testing club. So I'll add him to men's soccer. And let's refresh here. Oh, I think I made a mistake. It should be men's basketball.
Yeah, go ahead and change that. Okay, sorry to finish this up really quick. So as you can see here, once you're able to change permissions as an admin for different clubs, and you can see that I have access to basketball team. And also, I'm also able to access specific athlete rosters and athlete data for that team. So the type of data we have are raw data and also graphs and charts as well for all the different vendors. So we're short on time, so I'll just quickly go over and just show you different charts and data, but that is our demo.
Yeah, so we're gonna wrap out our demo and now it's gonna show a business value that we delivered.
Okay, after all those works, we want to highlight what we delivered at the end. So we delivered a system where initially the challenge was we had scattered data because of different platforms, and we developed a system where we have integrated data and centralized database where we get all the training and game performance of athletes in one place, and this improves accessibility for different staff and coaches and anyone who wants to use the system. And it enables for coaches to do actionable insights quickly by looking at various data of an athlete or a team. And this is a scalable system, like I mentioned earlier, which can adapt new technologies and grow. And lastly, we would like to say this system, I hope this system helps improve the performance and overall well-being of the SU athletics department and athletes. And we thank you for your attention, and we conclude our presentation. Thank you so much.
Yeah, thank you very much. We have time for one question, if you have. You mentioned data freshness of 5 minutes. I'm wondering, have you tried to push it to get fresher data, and what's the limit there?
Oh, so we can take up to 1 month recency of data, but we just check for new data every 5 minutes.
Which means new data shows up 5 minutes later, right?
Yeah.
What if I want to see my data every second, like a little work?
We don't have that implementation, but can easily implement like a button that would instantly refresh. But since there's a lot of data, typically we don't do too much because data from all different vendors can overload the system. So we did a 5-minute system to make sure that the system won't get overloaded with all this different data from different sources. And on top of that, you checked for any data that hasn't been uploaded every 5 minutes. If it's been 7 minutes without an upload, then it checks for stalling. So we decided that 5 minutes would be like a good middle point.
Right. Thank you very much. Well, next team is BlackPaigeWest.
So good afternoon, everyone. So we are Team CS 26.5. Our project name is College Fetch, and our sponsor is BlackPaigeWest. And in our team, we have Ben, Jessica, Victoria, and Tyson. And our faculty advisor is Professor Shin, and our sponsor is Michael from BlackPaigeWest. So to begin with our problem, so the problem is most college applications requires the same personal and academic information to be re-entered again and again. So for high school students, they spend a lot of time manually re-entering the identical information over like all different platforms and applications. And also high school counselors, they are spending a lot of time helping out the students, and also which takes time away from other important like tasks like essays, personal statement, financial aid application, and like schoolwork. And currently, there's no other existing platforms or tools that extract student data from transcript and directly into college applications.
Our solution is a Chrome web extension that is easily accessible for college students. And as you can see, we designed a nice and usable UI, and it has a lot of great UX functionality as well to be able to make the college application process as streamlined as possible. So the idea here is that it allows users to automatically upload their information to the extension. From there, you can click the autofill application button, and that will fill out the college form for them without having to manually enter in everything. And everything throughout the entire process of this Chrome extension is supposed to be as streamlined as possible. So we also have parsing functionality such that you can store grades from an existing student record. For example, it could be a transcript or Skyward, and then that information is populated into a cloud database where we can then put it into a college form. And then we also redesigned the UI. We were given a very bare bones UI, and we have lots of quality of life settings like dark mode, light mode, and then we also have things like help menu, and if you hover the mouse over these different buttons, it'll give a little tooltip to be able to explain what it does.
Okay, so onto the supporting components. If we take a look at the top right here, you'll see our mock Skyward page. And this is basically our version of a student transcript database just for our testing purposes. So at the top, you'll see some of the student information, but what we're really looking at is towards the bottom here. So we'll see that they're separated by 4 different years from freshman to senior year. And then below that, it's separated by the different trimesters from fall through spring. And what we're really looking at here is the subject, the course name, the course level, and the grade. This is all the information that we're storing into our database. And then at the bottom left here, we have our mock Skyward editor, which is basically for any of us or anyone on our team to go in and manually change, add, or remove any student data as they feel necessary.
Okay, so moving on to the user workflow that we were able to achieve. For us, the goal was to make it as simple as possible for the user. So what happens is the student logs into their College Fetch website and fills in all of their personal information. So that includes demographic, any grades, or anything they might want to include in their application. So then what happens is the student logs into their transcript database, which is Skyward. So the Skyward mock page that you saw earlier. And they're able to store all of the grades using the College Fetch browser extension, so only one click. And then the last step is the student logs into their Common App login, and they're able to fill out an application for any college they might be interested in. So what happens is College Fetch automatically fills out all the corresponding fields in that application.
So taking a deep dive into, I guess, the technical process of the parsing and the autofill. So here's our quick steps, I guess. So first, we're collecting manually entered data from the web page from the user that you saw earlier. And then we're parsing and scanning the transcript directly from Skyward. And then from here, we're storing it all into our MongoDB cloud database. And then once we have all that information stored in our database, we're matching the fields in the Common App. And then from here, it's the last step. We're autofilling it and then continuing on to the next field or the next page.
And now is time for the end-to-end demo. So here we are on the Common App, and I just opened up the Chrome extension. And the first thing that's going to happen is it's going to ask you to sign in. So I click the sign in button, and now I'm using Google Authentication to sign into the extension. Here's our webpage UI, where basically what you can do is fill in all of your personal information, and then that will be stored in the cloud database to later autofill. And we mentioned how you can also get your information automatically parsed. And this is showing that where we are on Skyward, I just parse the grades, and then right here in the webpage UI, all of that information is now stored in the database and is ready to be autofilled. And then the nice thing about this is that because we have the webpage UI, you can also modify it if you want to change something, if you think something. So there are 12 pages of classes, and all those classes were parsed directly from Skyward. And then moving on, I will show some autofill. There we go. Now we're back on the Common App, and I'm going to open up the extension, and I do one click. That's pretty quick, and it's all filled in. There's going to be a few fields that are not filled in because there are some niche things that we can't always support. And then this is a quality of life setting that we're supporting, which is autofill all, which instead of just filling in the existing tab, you can turn on that autofill all toggle, and then you click autofill application. And as you can see, both of those tabs are filled out. So it's very easy for users to use this extension.
And then just for some additional support, here we have our, I guess, course and grade section that we worked on. And not every school is requiring this, but just as an effort to extend the functionality into other local schools, we are having this feature here to store the coursing grids for another local school like the University of Washington. So here's our front page. And then if I go over to our academic section, we see that there's no courses stored at the moment. So I'm heading over to our Box Skyward page, and I'm entering my student ID. And then here are the previous different tabs that I was talking about a little earlier. So from here, I'm going to open our extension and click the Store Grades button. And then heading back onto our webpage section and give it a quick refresh, we see all of those grades are here directly from Skyward. And then now if we head over to the Common Application, into our 9th grade tab, we're going to open up the extension again. And then we're going to click the autofill button, and we see that it's automatically populating all of these fields directly from Skyward data that was there. And just jumping over to another tab, I'm going to repeat the process here for the 12th grade section. So clicking the autofill button, and then we see that it's populating it again directly from the 12th grade section of Skyward.
Great. So now we want to highlight how we're able to protect the student data while the system fills out the application forms. So since our project handles personal academic information, security was definitely treated as a priority. So it was built into the workflow of the application. First of all, we verify the user through the Google login process that you saw earlier in the demo, which helps the system understand who exactly is using it. Then through the OAuth flow, we add protections like PKCE and a one-time state value, which then help prevent someone from intercepting or faking that login process. And then once the user's actually logged in, all of the requests are going to be protected with the secure session as well as authorization checks. So the idea here is that the user should only be able to access and update their own information, not anyone else's. On top of that, we've also added some network protections as well, like HTTPS, HSTS, course and rate limitation, to just make sure to reduce the level of abusive requests. And to sort of sum up our security workflow, we first verify the user, then we protect each of the requests, and only then do we allow the user to access that sensitive data. And you see in the slide, I summarized this as the main three goals: verify, bound, and block. So we first confirm the identity before giving the access. Then we keep the users inside only of their own account. And then we block any risky or unexpected requests. So just the main takeaway here is that security in our project is layered. There's not one simple security check that does the entire work. Identity, ownership, and network controls all work together instead of relying on one single check. And then as for the project outcome, our question and our ask was to reduce the amount of manual effort put into college application process. Because students are dealing with a lot of things, and filling out that one application, let alone 20 applications of the repetitive work, might be a lot. And did we reach our goal? Yes, absolutely. Our project was able to successfully extract the students' data, like transcripts, like demographic data, and anything else. We also added more autofill coverage as well. So now it's not limited to just first and last name, date of birth, and transcripts. It's also volunteering, honors, anything else, any hobbies that might be included. So yes, we were able to achieve our goal. Thank you so much for your time, and please let us know if you have any questions.
Question?
So to the website like Skyward will block you from crawling all the data on it because it is some sensitive data. There's some block that you need to work on it to make it work.
Yeah, that's correct. So Skyward specifically does have that block. And what you need to do is you need to work directly with the school districts to be able to get access to that student information. So that's actually work on the behalf of our sponsor that we're currently in progress. And as you saw in the demo, we're currently using a mock Skyward page. So instead of using an actual Skyward, which we unfortunately haven't gotten access to, but we will soon, we're using the mock Skyward page to be able to test the functionality. And then to be able to get the data and prevent any of the Skyward blocking mechanisms, you reach out to the school districts.
Is this platform fully viable with Skyward, or are there other great websites and college application that it works for?
It is currently Skyward, and we are going to the project. We're going to support others in the future.
And to just kind of expand on that, Common App does support a lot of different colleges. So that's something that's really useful because it's not just limited to, for example, Seattle University or universities just in the area. It's limited kind of all over the country. There do exist other applications like Coalition App, but we've definitely made our application as scalable as possible to then be able to add those in the future if there's a need.
Thank you. Did you use any AI to map source data to target field? So you kind of like article information in publication.
So right now it's all it's trying to reduce the manual labor with that sort of easy data that you can put in. And then the next year's capstone project is going to be adding that LLM functionality to be able to have that more specific information. For example, if you have a question where it's something along the lines of, do you have a cousin that's been in the military for more than 6 years? Of course, we don't store that information in the cloud database. So you need an LLM to be able to get 100% coverage on these forms. So in the demo, you did see there's, I think, maybe one field that was not filled out. So that's a future priority to be able to get an LLM to answer those.
Just to clarify, was there any like subscription cost that would be in the final product, or would this be a free application?
Currently, no. As for the LLM integration, it's possible that there may be a subscription model, but we haven't implemented that yet. That's the next steps. But right now, no. It's free for students.
Yeah, and actually that's a really great question because we have looked into that kind of LLM coverage, and one of the main questions that we raised was if we did add the LLM component, would it add an additional cost for students? Because our goal is to make it as accessible to high school students as possible. So our priority would be to keeping it free.
Thank you very much. Thank you for attending. And that wraps up our meeting. Thank you very much.